Lecture 8. DISEASESW of rice Oryza sativa. Blast. Pericularia oryzae, sin. P. Gryza. Sexual stage, Magnopothe gryza. The disease was first recorded in China in 1637. In Japan, it is believed to have occurred as early as in 1704. In Italy, the disease called brucone was reported in 1828 and in USA in 1876. The disease was first recorded from Tanjore district of Tamil Nadu in 1918. Economic importance. The pathogen caused yield loss ranging from 30 to 61% depending upon the stage of infection. In severe cases, losses amounting to 70 to 80% of grain yield are reported. Symptoms. The fungus attacks the crop at all stages from seedlings in nursery to heading in main field. The typical symptoms appear on leaves, leaf sheath, rachis, nodes and even the glumes are also attacked. 3/4 leaf blast. On the leaves, the lesions start as small water-soaked bluish-green specks, soon enlarge and form characteristic spindle-shaped spots with gray center and dark brown margin. The spots join together as the disease progresses and large areas of the leaves dry up and wither. Similar spots are also formed on the sheath. Severely infected nursery and field show a burnt appearance. 3/4 node blast. In infected nodes, irregular black areas that encircle the nodes can be noticed. The affected nodes may break up and all the plant parts above the infected nodes may die. Node blast. 3/4 neck blast. At the flower emergence, the fungus attacks the peduncle which is engirdled, and the lesion turns to brownish black. This stage of infection is commonly referred to as rotten neck, neck rot, neck blast, panicle blast. In early neck infection, grain filling does not occur and the panicle remains erect like a dead heart caused by a stem borer. In the late infection, partial grain filling occurs. Small brown to black spots also may be observed on glumes of the heavily infected panicles. Leaf blast. Node blast. 3-celled Conidia. Etiology. The causal organism was first detected by Cavara in 1891 from Italy. Mycelium of the fungus is hyaline to olivaceous, septate and highly branched. Conidia are produced in clusters on long septate, olivaceous slender conidiophores. Conidia are piriform to obclavate or somewhat top-shaped, attached at the broader base by a hilum. Conidia are 3. Hyaline to pale olive green, usually 3-celled. The perfect state of the fungus is M. Gryza. It produces perithecia. The ascospores are hyaline, fusiform, 4-celled and slightly curved. The pathogen produces few toxins, namely, alpha-picolinic acid, pericularin and periculol. Disease cycle. Mycelium and Conidia in the infected straw and seeds are important sources of primary inoculum. The seed-borne inoculum fails to initiate the disease in the plains due to high soil temperature in June. In both tropical and temperate regions, the fungus overwinters in straw piles or grain. In tropics, one method of survival is through infection of collateral hosts such as Panicum repens, Digitaria marginata, Brachiaria mutica, Leivsia hexandra, Dinebra retroflexa, Echinocloa crusgulli, Setiria intermedia and Stenotifrum secundatum. The most probable source of pollination and initiation of the disease appear to be the grass hosts and early sown paddy crop. The disease cycle is short and most damage is caused by secondary infections. Air can carry the Conidia for long distances. The Conidia from these sources are carried by air currents to cause secondary spread. Most Conidia are released at night in the presence of dew or rain. Favorable conditions: application of excessive doses of nitrogenous fertilizer, intermittent drizzles, cloudy weather, high relative humidity 93 to 99%, low night temperature between 1520 C or less than 260 C, more number of rainy days, longer duration of dew, cloudy weather, slow wind movement and availability of collateral hosts. Forecasting blast of rice can be made on the basis of minimum night temperature range of 20-26 C in association with a high relative humidity range of 90% and above, lasting for a period of a week or more during any of the three susceptible phases of crop growth, viz. seedling stage, post-transplanting tillering stage and neck emergence stage. In Japan, the first leaf blast model was developed and named as BLAST. Later, based on different field experiments, various models were developed, namely, PYRICULARIA, PYRIVIEW, BLASTAM, and P-BLAST. A model to forecast the disease called Epibla has been evolved in India. Management 3/4 use of seeds from a disease-free crop. 3/4 grow-resistant varieties like Simhapuri, Tikna, Sriranga, Falguna, Swarnadhan, Swarnmukhi, MTU 7414, MTU 9992, MTU 1005, Swati, R64, R36, Shravani, Jaya, Vijaya, Ratna, RP 4214, IET 1444, IR20, TKM6, MTU 3 or 5 and NLR 9672 or 9674 in different tracts of Andhra Pradesh. 3/4 remove and destroy the weed hosts in the field bunds and channels. 3/4 split application of nitrogen and judicious application of nitrogenous fertilizer. 3/4 treat the seeds with Captan or Thiram or carbendazim or carboxyn or tricyclazole at 2 grams per kilogram. 3/4 seed treatment with biocontrol agent Trichoderma viride at 4 grams per kilogram or Pseudomonas fluorescens at 10 grams per kilogram of seed. Avoid close spacing of seedlings in the main field. 3/4 spray the nursery with carbendazim 25 grams or Edifenfos 25 ml for 8 cent nursery. 3/4 spray the main field with Edifenfos at 0.1% or carbendazim at 0.1% or tricyclazole at 0.06% or thiophanate methyl at 0.1%.